the lectures. Last week we finished up to here, this slides. I don't know why my screen is showing the face of these students. Okay. Last week we finished up to here, 15 or slide number 15, the flowchart of water treatment plants. Actually, this flowchart we used to mention once in the first chapter. Okay, in the first chapter. In here, there are the process unit operations and list of the unit operations and unit processes we normally used to treat water. In this slides, if we used the upland water, so there are several processes required to purify water. But if we use the lowland water, also same, but similar to the upland water, starting with the screening, understanding, and followed by the coagulations and floculations, sedimentations, rapid sand filter, and end up with the disinfections. But for the uplands water, maybe the disinfection is not required. But if we use groundwater it's nothing but just disinfect water before used. Coagulations, flocculation, sedimentations, rapid sand filters are not required. So just finish by the disinfections before distributing to the consumer's house or to the community. So if the groundwater is a hard water, some extra steps may be required. For example, lime soda softening. We apply lime to precipitate calciums and magnesiums. That is why the next we need to provide the sedimentation tanks, and we still need rapid cavity filters, and of course the disinfections before distributing the water to the community. So if it's the hard water, our process will be a little bit more complicated. Mostly the chemical, they are the chemical processed. These are the unit operations and unit processes used in a water treatment system. There are a number of unit operations and unit processes. So as I just want to emphasize again, unit operation, it's the unit that normally refers to the units that apply a physical process to remove the contaminants. But the unit processes, it's the units that apply a biological process or the chemical process to remove the contaminants. Basically, unit process is or refers to the units that applies chemicals and biological reactions to remove the contaminants from water. But unit operations depends on the physical characteristics of the contaminants. That is why only physical process is applied. So these are the flow diagrams. So things like this we normally call the flow diagrams. Starting from the first unit operation, followed by the seconds, the thirds, and end up with the treated water. So this kind of figures we normally call the the flow diagrams. Sometimes we add the fluoride. Sometimes we make up the deficiencies. If the raw water doesn't contain some fluorides, we want to promote the healthy of the fish. Maybe we can add some fluorides. but it depends on the raw water sources. In Thailand, additions of the fluorides are not required because we already have a lot in raw water resources in most part of the northern regions. That is why additions of the fluoride at the end is not required. Okay, but sometimes we have to add the oxygens. We have to aerate the water just to remove the taste and odor, or remove the irons and manganese, and oxidize some contaminants, some reducing agents in water. So, and in that case, pre-aerations may be required, especially for the groundwaters, but not for the surface water, as I mentioned in the exams questions. Another process which may be required at the very beginnings of the treatments, that is the pre-chlorinations. Chlorines may be applied in very first process, or may be applied again in the disinfections. So for the chlorines, if we apply it in the very first or the very beginnings of the treatment process, this process we normally call a pre-chlorinations. But if we apply the chlorine as the disinfectants in the last units before distributing water to the consumers, in this case, we normally call the post-chlorinations. So the major objectives of the pre-chlorination is just to oxidize some reducing agents, as I mentioned, mostly just to remove irons and manganese, so that interactions between irons and manganese with the chlorines will cause the precipitations, because it will change the oxidation reduction conditions in water. Additions of chlorines probably kill some algae. They can actually prevent the growth of algae in unit operations or unit processes, in several unit operations and unit processes, especially in the wall of the sedimentation tank. Additions of chlorines also help to reduce the colors and odor problems, reduce the slime formation. Slams is a kind of viscous liquids, similar. It's a kind of the viscous liquids stick it on the walls, the pipe walls, or the sedimentations wall, and any other places in water treatment systems. It's originated from the microorganisms. Some kind of bacteria, they are able to produce this slime, and this will create the problems, especially once slime is formed. It may release some organic compound which create the odorous problems to the water. That is why if we add a chlorine, so it helps to prevent the growth of the slime. So these are the objectives of the pre-chlorinations. But anyway, the pre-chlorination is not the major objectives is not to kill the germ. Okay, it's not to disinfect the microorganisms. We just add some certain amounts of chlorines to kill some algae and some bacteria, but not disinfect the germs. So we don't add too much. So we add some certain amount just to fulfill these objectives if our water contains some of these contaminants. But if there are no irons and manganese, if there are no colors and odor problems, pre-chlorination may not be required. Okay, so pre-chlorination. So why we have to add, when we have to add? So we normally inject chlorines in a high dosage, 2 to 5 milligrams per liter. Milligrams per liter, it's equivalent to ppm. So you may have heard about the ppm. ppm, it's the part per million. part per million. It's equivalent to milligrams per liter. So if you don't believe, you can prove it later. But anyway, we keep the choline at a high dosage. So this is enough to oxidize some reducing agents, get rid of the colors and odor, and prevent that slums formations, and of course, kill some algae. So this amount is actually very similar to the amount that we normally applied it to the swimming pools. For the swimming pools, at least we need like a 5 ppm. But for the normal water, the tapped water, the chlorine residue should be around 0.2 to maximums maybe 2 milligrams per liters only. It doesn't have to be like a 4 or 5 milligrams per liter. That is too high for the tapped water. But here, as it is for the pre-chlorination, so we use for many purposes. Sometimes we need a higher dosage. But anyway, for a good quality water like groundwater, it's not required. We don't have to add the chlorines. This pre-chlorination should not be used as a substitute of the post-chlorinations. Anyway, the post-chlorination or the disinfection is must be there. We have to keep this unit because additions of the chlorines we like to add, and then we want the chlorine left over in the water until it reaches the consumer's house or the point of use. So if we apply it at the very beginning, there will not be anything left because water still have to pass several unit operation and unit processes. Sometimes the mixing, sometimes have to keep it in a sedimentation tank. Sometimes water has to pass through the filters. So there's a possibility that all the chlorines will be gone. So pre-chlorination cannot be the only process that we apply the chlorines in the plants. Post-chlorination must be there anyway. For the turbid water, it's not recommended to use the pre-chlorinations. Okay, for the turbid water, if the water is too turbid, then we don't apply chlorine. Okay, in case if you want to kill the germs, pre-chlorination may need much greater quantities of the chlorine than the post-chlorinations, because some certain amount of chlorines may be react with some contaminants in water itself. Actually, these chapters, although the title is the water treatment process, but in fact, if you look into the contents of this chapter, this should be revised. These chapters, the chapter title should be like a physical-chemical process, because inside we are talking in details about the physical and the chemical treatment. So in combination, we normally call a physical-chemical process. Okay, so physical-chemical process, we apply this process in both water and wastewater treatment. So for wastewater treatments, as I mentioned, we normally classify it into two types, industrial wastewater and domestic wastewater. For wastewater treatments, we still need a physical-chemical process to remove the suspended solids. But once the suspended solids is completely removed, then we only have the organic matters, dissolved organic matters left, so that we apply the biological process to remove the organic matters again. But the details about the biological process we will discuss in the next chapter. So the next chapter, actually the title, it should be a biological process, but since the biological process is only used for wastewater treatment, that is why just to make it corresponding with the requirements from the Council of Engineers. So the next chapter, I just changed to the wastewater treatment process. But in fact, the details or the contents in the next chapter will be more on the biological process. Similar to this chapter, the details will be more on the physical chemical process. What are the difference between these two processes? Physical chemical process. So we apply some chemicals to modify the characteristic of the characteristic of the contaminants, such a very small or very fine particles. We will actually add the alums. We allows the alums to interact with the charge around the surface, so that the charge become neutralized, and that is why we can flocculate and coagulate them and let them settle in the sedimentation tank. So these are like the process we normally do it. It's a combination between the chemicals and physical process. That is why we call the physical chemical process. So this process, the objective is mainly to remove the suspended solids. And as we apply the chemicals, so that in terms of the volumes variation, sometimes the flow is high, sometimes the flow is low, or the quality variation. In the dry seasons, the turbidities in water is low, but in the wet seasons, there is much slides or landslides in the upland areas. Maybe at that time, the turbidities in water will increase. So this is we call quality variations. So if the turbidity increase up to like 3000 NTU, you have to add more chemicals. But if the turbidity is just only 40 to 50 NTU, so we just reduce the amount of chemical used. So in terms of the volumes and qualities variations, we can say that physical chemical, it's easy to adjust. But for the biological, it's very difficult, because biological process. So if you really look into the process, so who really drive the process? The biological process is like this. Organic matters, we add the oxygens, and then we allow the microorganisms to degrade the organic substance which come along with the wastewater. And this normally we measure in terms of the BOD. These organic matters get converted into a carbon dioxide and water molecules, which are the harmless end products of these reactions. So these reactions is actually derived by the bacteria. So bacteria play a role, important role in the degradations of the organic substance to becomes the harmless end product. So this will occur in the biological reactor or the aeration tank. If you come back to the wastewater flow rate, okay, so we will talk about it in the next few slides. Okay, so for this one, this will happen in the bioreactor. In the bioreactor, we provide the oxygens. Okay, so oxygens is provided. We cultivate the microorganisms inside, and then this microorganism received wastewater from outside. This wastewater contains some organic matters. So all the reactants are here in this reactor, so that these reactions can proceed. Okay, so this is a kind of the biological process. So we normally carry out these reactions whenever we treat the wastewater, because mostly wastewater, the major constituent is the organic substance. That is why For the wastewater treatments, we apply this process. So the details about the biological process will be discussed in the next chapter. I'm not sure. This is supposed to be a chapter 5, right? So next chapter is just chapter 6. Removal of the phosphorus. Phosphorus mostly can actually occur by using the chemical process. So we add calcium to precipitate the phosphate. So the most effective way to remove the phosphorus is by applying the physical chemical process. For biological process, it is very less efficiencies. We can say that normally it's a 0% of removal for the phosphorus by using the biological process. It may be removed, but very little amount. The sludge production's physical chemical process, we apply rapid and slow mixing, and then let it settle in the sedimentation tank. And then we also have like a filters. So the sludge production. So why does this sludge produced? So coagulations, and after that we allow the flux settles in the sedimentation tank. So mostly the sludge generated from the secondary sedimentation tank, and this sludge is normally in terms of the quantity is very high. In one day, water treatment plants may produce a huge amount of the sludge. Some plants, the larger plants, may produce up to several tons of the sludge, over 10 tons of the sludge for the large plants. That is why we have to handle the sludge properly. For the unstabilized sludge, we prefer the stable or stabilized sludge. Stable means the sludge exists in the forms that will not be resuspended again, or will not disintegrated to become small objects and get suspended back into the water bodies again. That is called a stabilized sludge. For the unstabilized, just like the jar test. So if you are doing the jar test, unfortunately this semester you are not able to do in the labs, but at the end of this semester, I'm not sure about the plans, the study plans in the a week before the examinations periods. As I have heard it from many people, they say that if it is necessary, 7 or to 10 days before the midterm exams period, so we are allowed to conduct the experiments in the labs, but I'm not sure whether we can do it in realities or not. But and I'm also not sure whether you will be able to come to the universities or not at that time. So if it is possible, then you can have a look how we carry out the jar test experiment. So for the jar test, normally we add alums. We determine the optimum dosage, and these alums will precipitate. We cause the precipitations of the fine particles, so that these fine particles will accumulate at the bottoms of the chamber. But once the pH change, or once we just little disturb or creates little turbulence in a jar, those sedimented sludge may be disintegrated and become smaller particles and resuspend again. So this kind of sludge, we call it, they are not stabilized. We only want the stabilized sludge, but we don't want unstabilized the sludge. Some sludge, just the pH of the water change, so it's resolubilized again. So get dissolved again. So this kind of a sludge we don't want. So for the physical chemical process, mostly the sludge are unstabilized, but for the biological process, the sludge are mostly stabilized. So we will talk about the sludge treatments and management again in the chapters after, in the next 2 chapters. For the operations and maintenance cost, biological process is very cheap. You don't need to add any extra chemicals except just providing the oxygens. But for the physical chemical process, we really need the chemicals. We need to add the chemicals. Okay, so the amount of the chemical added, we have to add it continuously. A large amount of chemical, we have to add it in a daily production. That is why we have to spend money for the alums and probably other coagulants just to be used as the substance to reduce the suspended particles, colloidal particles, sulfide particles. These are the water treatments processed. We essentially divided into 3 types of the treatments. The first types of the treatments is the primary treatments. Primary treatments mainly apply only the physical characteristic to remove the contaminants. Unit operations that applies only the physical characteristic, for example, screen. This is the only unit operation in this flow diagram that apply the physical process to remove the big objects from water. Okay, so this is a kind of preliminary treatment process. So preliminary treatment process, the objective is to remove the big objects by solely based on the physical process, or based on the physical characteristic of the contaminants. But if we add some chemicals, if we apply some biological process or chemical process, so this will be considered as the secondary treatments, because chemical process and biological process we apply so that the dissolved solids or the dissolved contaminants will be removed. Because after the preliminary treatment process, we expected all the suspended contaminants will be completely removed. Only the dissolved contaminants or very small contaminants left. So for small contaminants or the dissolved contaminants, we will let the secondary treatment process work on them. So that is why mostly the plants we apply primary treatments and secondary treatments. Mostly water treatment plants and wastewater treatment plants end up to the secondary treatments. So ordinarily pollutants are completely removed. Both the suspended or the dissolved forms are completely removed. But in some special case, there might be some contaminants left. There might be some something left, a small amount, but it may cause the significant effects to the consumers. That is why we have to provide extra treatments to remove those contaminants. So extra treatments, normally we call the tertiary treatments, or sometimes we call the advanced water and wastewater treatments process. For wastewater treatments, mostly we can remove the organic substance. But in some cases, if still there is nitrogen and phosphorus, if we want to remove these two pollutants, we have to apply some extra process, which is also part of the tertiary treatments to remove this N and P. Or even we already removed the dissolved and suspended solids from water, but there is some pollutants left, the pollutants which may create the taste and odor. In that case, we have to apply the adsorption process. So this adsorption is considered as the tertiary treatment process. So these are three different treatments process. We normally classify it according to the contaminant characteristics. So you can have a look in the details again later. And this is the flow charts of the wastewater treatments or the biological treatments process. Wastewater treatments, they are mainly apply the biological process to remove the contaminants. You will find they use the coarse screen, grit chamber, oil grease remover, and even the micro screen. So these are part of the preliminary treatment process or the primary treatment process. Primary settling is also part of the preliminary treatment process. Okay, so this process basically remove the contaminants by considering or applying only the physical process only. Okay, they don't apply any chemicals. They don't allow the biological reactions happen. So just remove the contaminants based solely on the physical process. But once all the dissolved, all the suspended solids completely removed, then only the dissolved organic matters are left. So these organic matters can be purified or can be removed by the biological process. The bacteria will do this job, as I mentioned in the reaction. So the bacteria, once they utilize the organic matters, they also grow up. We need to remove these bacterial cells from the treated water. That is why we have to provide a califier or the sedimentation tank. And at the end, we have to discharge the supernatant to the receiving stream. Disinfection may be required or may not be required for a wastewater treatment, depending on the receiving stream. So if we discharge the treated wastewater into the river, which pass through the city, in that case, disinfection may be strongly recommended. But if we discharge somewhere outside or in the downstream part, disinfection may not be required. So I'm talking about the wastewater. For the treated wastewater, we just dispose the treated water into the natures again. That is not required for the disinfections. And some other process we also need to apply to handle the sludge. So we will talk about this sludge treatments again in next two chapters. On grease removal, primary settling are part of the primary treatment. Rapid mixings, coagulations, and floculations. Rapid mixings followed by the slow mixings. These are the unit process we use to carry out the coagulations and flocculation process. Irons and manganese. How do we remove the irons and manganese from water? So for irons and manganese, we can actually do like this. According to the chemical characteristic, we all know that the iron, if you normally the islands, if we withdraw the water from underground, the irons will completely dissolve and exist in the form of Fe2 plus. For manganese, also the same. They also exist in the forms of Mn2 plus. But if we expose these two with the oxygens, these irons will react with the oxygens and becomes Fe2O3, and this is the precipitated forms. The same as the manganese. If we exposed water containing manganese with the air, we will get MnO2. This is also the precipitated forms. So once we expose the water like this, we allowed water passing through the tray. Water is pumped from the groundwater well and then flowing to this unit. So water just flow over this tray and then fall to the second tray and then again fall to the third tray like this. So once the water flows, so it has a chance to expose it to the oxygens. So oxygens can actually get dissolved into this water and react with the irons and manganese. So it becomes the precipitated forms. That is why in the next unit operation, we should actually provide sedimentation tanks or any forms of tanks which allows the irons and manganese precipitate. So this is the procedure. We remove Fe and Mn from especially groundwater. From surface water, there would not be any problems because water is already exposed to the oxygens. Only few amount of the dissolved irons and manganese exist. For the surface water, these flow diagrams is basically the same as the previous one, but just different formats. From the water resources, pumps is used. Water is passing through the screen, and during traveling from the screen to the rapid mixing, some disinfectants and coagulants are added. That is why the rapid mixing occurs in the next unit processes. And next to the rapid mixing, we need to provide the slow mixing chamber. This slow mixing chamber is used to promote the conglomeration amongst the colloidal particles. So such a very small particles become a bigger and then finally can precipitate it to the bottoms of the chamber. Okay. Sometimes the pH adjustment may be required if we use the coagulants, which really needs very specific the pH range, low pH range or higher pH range. So before before processing to the next unit operations or unit processes, we need to make up the pH to be in the neutral range again. That is why we need to have the pH adjustment process after the floculations and coagulations and flocculation. Next, there is a filter and clear well. Normally in the clear well, it is the chamber that we use to keep the produces water. And in this chamber, we also add the chlorines. Okay, chlorine is normally added in a clear well. Okay, so these are all about the typical idea about the water treatment plant. So in this afternoon, I would encourage you to have a look the video clips so you get more understanding about the water treatment process. And if you once you completed watching the video, you can come back to these slides again and just to have a look. So how the water flowing from the first unit operation to the next unit operation, or the unit processes. Okay, so just come to the preliminary treatment, which is the first topics, actually the second topics to this chapter. So preliminary treatments essentially consist of these following uh, 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 unit operations, or the equipments: screen, commit neuter, grit removal, oil and grease removal. It's also part of the primary treatment process. And the last one is the pre-aeration. So these are the unit operation, unit processes commonly used as the primary treatment process. Uh, these are the figures describing the applications of the primary treatment uh, equipment or a unit processes: screening, grit removal, pre-aerations, and flocculation. So sometimes the pre-aerations and flocculations can also be used as the uh, pre-treatment process. Okay, so we just move to the first unit operations, which is installed everywhere and in both water and wastewater treatment plant. The objective of the screens is just to remove the cost and even fight objects. So these objects get entangled in the mechanical equipment if we don't remove them. Just imagine about the sands or gravel. So once it get into the pump's impeller, it may cause the damage. So if it happens 1 or 2 times, it won't be creating the problems. But if it's always happen, uh, you will find the impellers may be corroded or damaged. So we have to remove this before entering to the pumping facilities. So some pumps they are really fractured, so that is why we have to protect them. But for the larger pumps, it may be okay. The objectives of the screens, yes, we remove this just to protect the pump's impeller. How the screen look like? This is a photograph of the screens used as the wastewater treatment plant. So the screen is installed in the channel like this, in this channel like this. And then if we take a look at the cross sections of this equipment, you will find how it works. This is how it works. Water just flow through the channel. Water just flow through the channels. And if there is the objects stick onto the screen, sometimes the mechanical equipment, this mechanical equipment will move down and then remove all the trash from water. This is how the screen work. And there is also one issue relating regarding to the design of the screens. The designing of the screens, you may have to consider the height difference between before entering the screens and after entering the screens. So anything we put it in a waterway, in a piping system, or in the channel, it will always create the head loss. Okay, even these screens, it will also create the head loss. So according, in fact, this figure is not completely correct. If you really take a look at the water levels, you will find water levels is upstream to the screen is a few millimeters above the water levels after passing the screen. This few millimeters difference is actually due to the screen. Anything which blocked the waterway will always create the head loss. This one is also same thing. So now, unfortunately, it is the time that I really need to leave. If it is possible, I will make a video clips regarding to this screen and probably grid chamber, so that if you have time, you can have a look again later. I really need to leave now. Do you have any question regarding to the today's lectures, or maybe some other things, other issue related to the class? มีคำถามอะไรเพิ่มเติมไหมครับ